Welcome back. Now, types of spectroscopic methods of analysis. So, what are the types? Spectroscopic methods of analysis are based on the measurement of electromagnetic radiation emitted or absorbed by solute or sample, as we discussed earlier. So, what are the types actually? So, two most common photometric methods are colorimetry and spectrophotometry. Colorimetry is like inaccurate most of the time, but the most accurate is spectrophotometry. Colorimetry we can like 400 to 800 nanometer, which is visible, and spectrophotometry is UV 185 to 400 nanometer. Now, IR, which is for 0.76 to 15 micrometer. Now we can see here's a source. Now here's a monochromator. Now here's the source holder or sample holder actually. Now when the monochromator suits like wavelength max, which is like lambda max, we can detect how much light is transmitted and how much light is absorbed. Now the amplifier part. What does amplifier do? It amplifies the electric current if required. Now the recorder, which will record the result. Now, sources of radiation. It provides sufficient intensity over the wavelength region. Two sources are required to scan the entire UV-VI span. Deuterium lamp and tungsten lamp. In deuterium lamp covers the UV region like 190 to 350 nanometer, and the tungsten lamp covers 330 to 780 visible range. These are the diagrams like how it's possible. Now, what's monochromator? So here we can see monochromator. The role of monochromator is to provide monochromatic light. Like quartz prism is used for UV region and glass prism are used for visible region. Here we can see the quartz prism is like this and the glass prism is like this. Now, what sample holder? It should look like this. The glass one should look like this and the quartz one should look like this. So virtually all UV spectra recorded solid surface. Cells can be made of plastic, glass, or quartz. Only quartz is transparent in the full 200 to 700 nanometer range. So, what's the suitable one? The plastic and glass invisible spectra. Okay. Now, concentration is empirically determined. A typical sample cell, which is known as cuvette, as we discussed earlier. Now, what's detector? Detector converts the electromagnetic radiation into electron flow and current of voltage. The photocurrent is amplified if necessary. As we said earlier, that if it's required, it will be amplified. And then there is a recorder to digital display device. Example, phototube, photomultiplier tube, or photovoltaic tube. Here is vacuum phototube. Here is sunlight coming. Here is anode, and obvious it's cathode. Now it's the tube. Now, in practical, we can see like copper sulfate and ferrous sulfate. So in copper sulfate, the wavelength, the maximum wavelength or the maximum, what is that? Okay, lambda max is 620 nanometer now, and the lambda max for ferrous sulfate is 530 nanometer. So what's lambda max? Lambda max is it is the wavelength which shows maximum absorbance. So here is absorbance and here is lambda. So where is the lambda max? Where is the absorbance is highest here. Now applications of UV visible spectrophotometry. Qualitative analysis. The if the quality of the compound is identified, then it is qualitative analysis. UV visible spectrum of one non-organic compound. Now quantitative, based on pH law. If the concentration is like higher or lower, we will be based on that.